Hello, my name is Jens. I'm one of the developers of the Sparrow Verification package, and I'm here to show you how it all works. Sparrow Verification is designed to find and identify errors in your Unity projects and help you fix them. The bigger your project, the more of those inconsistencies and small errors might be there, being missing references, small things that don't work anymore, audio files that don't have the right import settings, stuff like that. That's what our system is designed to help you fix and make your project consistent and working. Right here you see the Sparrow Verification window, which you can open up via the Window Sparrow Verification menu. It's designed to look and feel like any other Unity window, so that it fits your workflows as good as possible. At the top, we have the big Scan Now button, which has a play icon. When you hit it, it's going to scan your project for little inconsistencies and errors. For example, we have an entry here for a missing script that has been found on the game object called example missing script. And when I open it, you can see that there indeed is a missing script on this object. And I could now go ahead and fix this. Finding all of these small things can be a pain in big projects, so Sparrow is here to help you find them for you. Now let's dive into the features. First off, you have some options for what you want to scan. When you run the scan, you can scan just a couple of game objects that you've selected using the selection option. You can scan the scene that you have opened, which is the option I've just used a few seconds ago. But you can also scan the whole project or all the assets in your project, or just everything, which I usually use just to see all of the things that I could fix, that I should fix in my project. Now, you might get different results depending on what you scan. Performing the scan within this scene gives me these 4 results, but I could also scan all the assets in the project, which gives me different results because now it has scanned different things in my project. For example, I can see some import settings on an audio file that are not right, and I could go ahead and fix them. In addition to selecting what I want to scan, let me just perform an open scene scan real quick. I can also define what checks I want to perform on these objects. And this is what we call the profile system. Using the profile system, you can go ahead and define various profiles for different kinds of work you want to perform in your project. For example, as an artist, you might not be interested in audio import settings. Or as a programmer, you might not care about texture sizes at the moment, but using the profile system, you can kind of trim what checks the system performs to your needs, so you only see the warnings and errors that are relevant to you. We ship the system with a couple of standard profiles called artist, audio, and programmer, as well as a default profile, but you can always add a new profile if you need one, if you have more specific needs. In our projects, we're also game developers and use this system in our projects. We have a couple more profiles running, but these defaults should give you a good head start. You can edit all of the profiles. They're just a scriptable object in your project. And when editing these profiles, you see you can really fine-tune which checks should be performed on your system. You can turn them on and off. You can decide if they should show up as an info or warning or as an error. You always get a small description of what the check is about. And for some of the checks, you can also set up some additional settings. So for example, for the check large texture sizes, you can define which sizes would count as a too large texture. Now the default is 2048, but you can also define what kind of texture size should count as too big within your project. For some of these options, there's also more and larger settings that you want to perform, and we'll go into detail for those later. But that's pretty much it for the profiles. for some of the checks that we've implemented, we've defined a fix, an automatic fix to resolve those issues. You can also define these fixes yourself when you extend the system. These fixes should always be looked at with caution. An automatic fix can't solve every problem. For example, we debated if we want to offer an automatic fix for the missing script error. So when missing script is on an object, should we just remove it when you choose to automatically fix this? And we've decided against this because just removing the script would not fix the issue. It was just hide the issue and maybe cause some trouble down the line. So for some of the checks, we've decided not to offer an automatic fix, even though there might be a way to implement it. And this is a feature that really should be used with caution. We've implemented automatic fixes where we believe it makes sense, and you can do so as well. And when you find something that you want to fix automatically, you always have this fix button next to the test result. And you can also fix all of the checks at the same time by selecting all of them and then hitting the fix selected button on the top right corner. Your project is always going to be unique. So we've made sure that there are a couple of ways to add checks and consistency tests to your own code and ways for you to customize how the system works for you. So to show you how the system works and how you can check your own code, I've prepared a small example class called the Player Manager. Now in the Player Manager we have player health. We have a link to a game object, which is supposed to be the player object, and we have player anchors, which is a list of transforms. Maybe these are the bones of the player or their collision volumes, something like that. So something we have to set up in the editor for this player manager to work. One of the ways to add checks to your own logic and to make sure that this player object, for example, is always assigned and never not assigned is the iVerify interface. You can just add it to your class and then implement it. And it's going to add you one method that you can fill with logic. This method is basically, that's what's called when you press the play button in the verification window. It's never called during builds unless you call it yourself. However, what I like to do is surround the logic in here within the compiler conditioner, just to make double sure that this has no impact on builds at all. And in here, now we can check if, for example, the player object is set. So I just write checker.check, and this is basically an assertion. So what I want to do is check if the player object is not null. And if the player object is null, I want to write out the message player object is null. I could also give it the game object where this error originated from, but this is optional. So now what we've done is we've added a check if the player object is null, and it's going to find this. So now you can be sure when you write your code that the player object will be assigned. There's also alternatives and easier ways to do this. You could, for example, use the method check.not_null, which is really just a shorthand. And there we could use this syntax, which is basically the same. It checks if the player object is null, and if it is null, it's going to give an error message saying player object is null. You could also use the checker.check elements not null for the player anchors. Now this check elements not null goes through a list and checks if any of the elements in this list are empty, are null. We have various of these helper functions that you can use when programming. You can find them in the documentation, but we've also made sure that they're pretty understandable during coding. All right. Now what we could add is a automatic fix. For example, if the player object is null, we could add a fix, which is always a Unity action, which maybe tries to find this player object. So player object equals game object dot find player object. Now this attempts to fix the problem, but we are not sure always if the right object has been found, if it finds one, or if it stays null. So this, as I've said earlier, these automatic fixes have to be seen with a grain of salt, but they can help make your workflow a bit faster. So this is how you set them up. Also, you can assign a category. The category is what you see on the left here in the verification window. So any failed check always has a category. For example, the reminders would be a category, and then a description, which is reminder. This is a reminder. And we see this here as well, where we can assign a category, and the player object is null, would be our description. Now, using the iVerify interface allows you to write some cool checks, sophisticated checks, to see if everything is set up correctly. But these checks that we've written here are pretty basic. So what we've added is a way to check for these things faster, and that's called the attributes. For example, we are checking if the player object is null. And for this, we have an attribute that you can just add, which is called vRequired. So this is equivalent to what we've written earlier. It's going to give you an error when the player object is not assigned or null. So the vRequired always makes sure that these things are assigned. You can also use some others. For example, non-null elements, which is going to check the list if there are no null elements in there. And if there are some null elements, it's going to give you an error. Or for example, the vRange component, where you can assign a min and max value for example, integers. So if we want to make sure that the player health is always between 0 and 100, we could do this using this vRange check. So now we've really quickly set up some checks and made sure that these values are always consistent and correct, using just these attributes, which are really fast to use once you're used to them. Okay, so we've seen how to use the iVerify interface and the attributes to check your code for things like variables that are null or integers that are not within a specific range. And using the iVerify interface, you can really do some sophisticated stuff. But there's another way to add even more logic, even more checks to your project, and that's called writing your own check. So the system performs a number of checks when it goes through the project, and you can see them when you look at the profile editor. And the iVerify interface is just one of those checks. You can see it here. So it's implementing the base check class, and you can turn it on and off. And you can write your own checks that way yourself, and these can perform even more sophisticated things like scanning assets in your project, or scanning project-wide settings and making sure that these are correct, things that you might not want to put on single game objects or into single scripts on mono behaviors. So to add your own check like that, we just create a new script, call it my new verification check. There we go. Now we edit it, and I'm just gonna take this out. And what we do for this to be a check, we just let it inherit from verified check base. And that's pretty much it. That's pretty much all that we have to do. And now we can add some additional logic. So for example, if we wanted to check all of the game objects that are in our system or that are selected to be checked right now, we just override the function perform check on game objects. And now we can check if this game object is adhering to some of our criteria. So for example, if the name equals test, we could add a failed check called no game object should be named test. And now we've added a check that is going to check all of the game objects that are being scanned during the current scan and check their name. Now this is pretty basic and not really powerful, but we can also override this for other types. For example, for meshes, for mono behaviors, for shaders, for scriptable objects, for sprites. And using the system, for example, to check all of the audio clips in our project can be quite powerful. And we'll see how we are using this logic to ensure that the import settings for audio clips are consistent within your project. To make sure that this check shows up with a nice category and description in a verification window, you can also override this the two strings called long description and description. So we could say game object test name is the description for our new check, and the long description should be or could be checks if a game object dares to be called test. All right, this is the logic. Now to add it to the verification system, there's not really much that we have to do. We can create a game object that is called test and then run a scan, and we already see the new result in the verification window. We have the game object test name, no game object should be named test, with a link to the object. That's pretty much all that you have to do. Now in the background we are using reflection to add this class that you've written to the list of checks that are performed. So you don't really have to do anything more than just write this on one class. You don't have to add it somewhere, you don't have to assign it to anything. It even shows up in profiles now with some settings that you can turn it on and off. You can set if it's an error warning or an info. All right, let me show you how you can add a custom editor to the profile window so that people can fine-tune the checks that you've written for their own profiles. We've already seen how we coded this game object test name check. I'll just add a little string to it called forbidden name. It's going to equal test, but we are going to use it to make sure that this name is the name that is forbidden. So I'll just check if the object name equals the forbidden name, and then we will just also add this to our error message. Be quick. All right, so now we've changed the class to always check against this forbidden name variable, and now we want to allow our users to change this. So for this, all you have to do is override this method called draw specific profile editor. And once we've implemented that, it's going to render all the profile settings to the profile editor. Now you'll notice that it returns that you have to return a Boolean, and this is to make sure that the system saves the changes. So if somebody entered a new name that is forbidden into the editor, you would return true, so that the profile scriptable objects would be serialized and saved, and the changes are consistent in the scriptable object. So what we can do is just give the users a text field where they can enter the forbidden name, and you'll notice once I've saved this that we have the option to enter this name in the profile editor once it has compiled. So now we can here enter the forbidden name into the system, but as I've said earlier, we have to return true if something has changed. Now there are a couple of ways to do this. I'll just use a forbidden name buffer, which I'll set to the forbidden name, and then I'll return if the forbidden name buffer equals the new forbidden name. Okay, so now we've set it up so the changes are also saved into our profiles. So I can now give it another forbidden name, for example, hello, and it's going to be saved. And now when I run the check on the open scene, I don't get the result for the test object because test is no longer the forbidden name. But once I edit it to hello, I get this check. Now, checking if a game object is called hello is not the most powerful thing. This is just an example, but you can create your own logic and check all of the things in your project using this logic, using different kinds of checks that you perform on things, and you can also write checks that check other things than game objects, for example audio clips, as I've mentioned earlier. There are a couple of these override methods that you can use. Just look in this list, but it's also in our documentation where you can see what you can do. And also if there's something missing, just let us know. We are using the system ourselves, and we are also extending the systems to be as useful as possible. So your feedback is very much appreciated. All right, let's take a look at another powerful feature of the Sparrow verification package, and that is the import settings. Now, when you have a large project, you might have run into the problem of having inconsistent import settings. For example, for voiceover audio and music audio, you want to have different kinds of import settings. And once you reach a couple of hundred assets in your project, it's really hard to keep track of all of these import settings and make sure that everything is right. And these things can really kill the performance of your game. So what we've done is we've written a couple of systems to check all of the assets in your project and make sure that the settings are consistent. You'll see when I perform an asset scan here that I've prepared one of these import settings errors where we see this test audio file that we have in our project has the wrong preset settings in the forced to mono setting. You see it here in the verification window. And indeed, we see that forced to mono is turned off. Now I can automatically fix this using the fix button. And here I recommend using the fix button because it automatically sets all of the import settings for this file for you. So now that I've pressed this, you see forced to mono has been turned on. And using this, and especially using this for hundreds of files at the same time, really makes it fast to set import settings in your project. You can fine-tune what these import settings are supposed to be. In the release version, we have import settings implemented for 2D art, so sprites and textures, for audio, and also for meshes, which we call FBXs. And for each of these import settings in the profile, you can give it a path where these files should sit and an import setting preset. So the idea behind the system is that you would, for example, have a music folder for all of the music in your game. And within this music folder, you would want to have all of the audio clips to have consistent import settings. So maybe if it's a music piece, you want it to be set on streaming and not on decompress on load. So here you can set up the path, for example, the path to the music in your game, and then pair it with an import setting preset. You can add as many of these folders as you'd like. In this example, we only have one. And for these presets, which are just scriptable objects, you can now fine-tune which of these settings you want to check, which is the checkbox on the left, and then what the setting for this should be. So if we only want to check if force to mono is turned on, this would be how we set up the scriptable object. And all of these other settings that are not force to mono are ignored. They are not checked. And now we enforce force to mono to be turned on. I can create these scriptable objects and these presets using a right click and then create Sparrow Verification import settings, and then we have these presets here. And for different folders I can use different presets. For example, I could check if the quality is set to 50 in a specific folder. And now I can fine-tune what the settings are supposed to be for music, what the settings are supposed to be for voiceovers, for SFX, for sprites, for textures. You can use this system to really check hundreds of files at the same time, and then using the Fix All button to also set the import settings for hundreds of files at the same time. So this is a pretty powerful system that you can use. That's pretty much it for the release version of Sparrow Verification. I hope that this tutorial has been helpful. As I've said, it's the release version. We are using this in our game development projects as well, so we are constantly extending the system to our needs. If you have something that you'd like to see in the project, in the system, let us know. Give us our feedback, and we'll do our best to implement it. This is version 1.0. There's going to be a version 1.1 and so on. We have a roadmap in mind of where this is going. So your feedback is valued a lot. So join us on Discord and let us know what you think. Bye bye.